Hi, this is Jaden Han, and this is lesson 2 for YLOC 7th grade. So the first set of problems requires you to write the equation or inequality. So let's try out number 1 and 3. So the first question states the sum of 42 in a number is equal to 51. So when you read sum here, you should automatically know that sum means addition. So it just says 42 plus n is equal to 51. So let's write that out. And all you have to do now is isolate the variable by subtracting 42. And you should get n equals 9. All right, let's try out number 3. The product of 9 and the quantity 5 more than the number t is less than 6. All right, so product means that you're basically you're multiplying. So it should say the product of 9 and the quantity 5 more than a number t. So we have 9 here, and you're multiplying it to something that is 5 more greater than t. And it should be less than 6. So that's how you would get your final answer. Or you would get the equation. All right, the next section requires you to check whether the given number is a solution of the equation or inequality. So we'll try out 1 and 3. So 15 minus 4y is greater than 6, and we have to plug in the number 2. So let's check. So 15 minus, and we'd plug in 2 wherever it says y. So let's simplify that. 15 minus, and 4 times 2 is 8. And then 15 minus 8 is 7. So is 7 greater than 6? Yes, it is. So this inequality is correct. Okay, let's try out number 3. X minus 5 divided by 3 is greater than or equal to 2.8. And we're plugging in number 11. So let's plug in 11. So 11 minus 5 is greater than 3. 2.8. So 11 minus 5 is 6. So 6 divided by 3 is 2. So is 2 greater than or equal to 2.8? Well, it's not. So this inequality is incorrect. Identify the domain and range of the table and tell whether the pairing is a function. All right, so let's try out number 1 and 2. Okay, so the domain for this, well, as you know, domain is for the x values. And the range is for the y values. So then, the input essentially are the x values, and the output is y values. So the domain for this one, whenever you have a set of numbers they give you, that would be the domain. So you put it in brackets and then sort it from greatest to least to greatest. So 1, 2, 3. 0, 1, 2, 3 would be your domain in these like brackets, or I forgot what they're called, the squiggly lines, I guess. So just remember, when they give you a set of values, that's going to be your domain and range. So then the range would also be 5, 7, 15, 44. So next we have to determine whether the pairing is a function. So the best way to test if something is a function is to see if it passes the vertical line test. So let's try that out. So what I'm gonna do is use a graphing calculator, or like a graphing calculator that could kind of help us. So I'll plot out all of the points. So 0, 5, 1, 7, 2, 15, and 3, 44. So we have the points plotted out right now. And then let me kind of try drawing a line of best fit. Looks like it will be a curve. So hold on. Okay. So this is kind of a line of best fit. And so the way you determine how something is a function is if it passes the vertical line test. And that means if you draw a vertical line at any point in this graph, does it only touch one place? Well, the answer is yes. So therefore, this is a function. All right, let's try out the next problem. All right, number 2. So as mentioned previously, the input will be the domain and the output will be the range. So the input for this one is the set we're given. So 1/2, 2/3, 3/4, and 3/4. So, and the range would be 0, 1, 3, and 5. So now let's try plotting these all out to see if these are, if this is a function or not. So we have the graphing calculator here. Usually you're supposed to plot it out by hand, but I think it's a bit hard to do that right now. So let's just try using this method. So as you could see, this graph has 2 of the same x values. They both have 3/4. So let's see what would happen. Oh, wait, let's see what happens if the graph is both, if they have the same x value. So I graphed that out. So let's see if this passes the vertical line test. So if you draw a point at any value and it only touches one point of the graph, then it's correct. But if you could see here at 3/4, it will be touching 2 points of the graph. Since two points of the graph have the same x value. So that means that this would not pass the vertical line test and it's not a function. So it's a rule of thumb. If it has the same x value, if 2 points share the same x value, it would not be a function. Okay, let's make a table for the function now. So identify the range of the function. So we have x plus 3.5 here. So we just have to plug in. So the domain will be 4, 5, 7, 8, and 12. And we just have to plug in what corresponds to that point. So y equals x plus 3.5. So if we have x here, we can just plug in x to find the y. So y equals 4 plus 3.5. And that would equal 7.5. And we just keep on repeating. So y equals 5 plus 3.5. That would be 8.5. So y equals 7 plus 3.5. That would be 10.5. Y equals 8 plus 3.5. Well, that's 11.5. And y equals 12 plus 3.5. That's 15.5. And that's what you would need to do to find the range. And if you're given the range, you could find the domain if they give you the equation as well. So the range would be, so remember to use these brackets, 7.5, 8.5, 10.5, 11.5, and 15.5. All right. Let's move on to the next set of problems. So expression ft plus ac represents the total number of vertices of T tetrahedrons and C cubes, which expression also represents the total number of their vertices. So as you could see from this equation, we could factor out a common factor between the two. So as you could see, both 4 and 8 are divisible by 4. So if you divide 4 out of this equation, you get 4 times T plus 2C. And that'll get you your final answer of that, of C, basically. All right. Write an inequality for the greatest number of six-packs that can be created of 86 bottles of water. Be sure to show your work. So let X equal the number of packs. All right. So let's say we had one pack. Then that would be 6 bottles of water. So we don't want the total number of bottles of water to exceed 86. So we would use the sign greater than or less than or equal to. It has to be less than or equal to 86. So we have that point of the equation down. And as mentioned previously, if we add 1 pack of water, then it would be 6 bottles of water. So then if there are 2 packs of water, it'd be 12 bottles of water. So then this one would be 6x, since we're multiplying the number of packs of water with 6. And that'll get your final answer of C. All right. Thank you for listening, and that's all for today.